Hello, welcome to the course Excelling with Mathematical Modeling. Today we will be learning about how to solve these difference equations with the help of Microsoft Excel. In my previous lecture, we have come across the solution of the difference equation in the form un equal to ck to the power n, where c is an arbitrary constant. And we have seen that for various values of k, how the solution behaves. For example, if it is k is greater than 1, we get the solution that as n increases, the solution becomes unbounded. When k lies between 0 and 1, as your n increases, the solution converges to 0 or the solution decreases. If k lies between minus 1 and 0, then there is a oscillatory behavior, but a damping oscillation, and ultimately the solution decreases. And at the end, if k is less than minus 1, then we have the same damping oscillations, but with increasing magnitude. So, now what we will do is we will replicate these solutions with the help of Microsoft Excel. So, our solution is of the form un equal to ck to the power n. Now, I have taken the initial value of c to be 10, k is greater than 1, so I put 1.5, k lies between 0 and 1, I put 0.5, k is less than 0 and k is, so minus 1 less than k less than 0, I put minus 0.5, and k is less than minus 1, I put minus 1.5. So, we will be solving and visualize the solution for these different values of k. To start with, I put this value to be 0 and this is equal to, I give an increment of 1 and calculate these values. Now, the first un, that is when k is greater than 1. So, in that particular case, this is equal to, so if I put n equal to 0 here, I get c k to the power 0, so the value is c. So, I can write u0 equal to c, which is this value, multiplied by k to the power 0. Now, C9, the value of C is a constant value, so I put a dollar, value of k, again a constant, so I put another dollar here, and g to the power 7. So, I get this value and I drag the next 10 values. So, if I want to plot them now, I will highlight this by pressing Shift and the cursor key, go to Insert, go to this scattered diagram, and instead of choosing this continuous line, I will choose this one, so that you get an idea that these are the points, the dots, and we have joined those points because they are discrete case, and we have get a curve like this. If you want to change the title, you can just type this is k greater than 1, and in bracket you can just write k equal to 1.5. Now, let us move when your k is lying between 0 and 1. The value is 0.5. So, again this is equal to c, which is this value, multiplied by k, which is 0.5, and to the power 0. This is a constant, and the value of k is also taken to be constant, which is 0.5. and I drag them. Now, to plot this particular column and this particular column, what you have to do is you have to first highlight this by pressing the shift key and the cursor, then go there, press the control button, choose this one, press shift and then the down cursor, and this will be highlighted. Then you go to insert, again choose this and this particular figure. So, when your key lies between 0 and 1, you have a decreasing value of the curve. Now, let us draw this one. This is the value of k is minus 0.5 here. So, this is equal to again c multiplied by k to the power n, which is 0 here. This c is constant, and the value of k is also constant. So, while dragging, you make sure that your plus sign changes from this to a smaller one with black. So, and you drag them and you get all these values. Again, to choose this and this, you have to first highlight this, press shift, choose these 11 values, press control, go here, highlight this, and then press the shift key and the down arrow, and you will get these two columns highlighted. Go to insert, click this chart, and again you get this. So, you get an oscillatory behavior, but decreasing, a damping one, which ultimately goes to 0. And the final one is again equal to c, which is 10 multiplied by k, which is minus 1.5 and to the power 0, where c is a constant and this 13 is also a constant, minus 1.5. You get this value, you drag them. So, again, if I highlight this one by pressing shift and the down arrow key, this is highlighted, press control, go to this cell, click, highlighted, press the shift and the down arrow. So, this will be, both the columns have been chosen, go to insert, go to this chart and again click this. So, now you get the values where the oscillation is increasing for the value of k which is less than minus 1. I already have these charts here. So, the first one tells you that okay, this is when k is greater than 1, the value increases unboundedly. When k lies between 0 and 1, then the value decreases and ultimately goes decreasing. In this case, it goes to 0. When minus 1 less than k less than 0, it is an oscillatory behavior, but a damping oscillation where the oscillation slowly decreases and dies out. And when k is less than minus 1, then again it is an oscillatory behavior, but in this particular case the oscillation increases as n increases. So, these are the 4 dynamics which we have already seen here. These are the 4 dynamics, and we have just solved this equation with the help of Microsoft Excel to get a replica of these curves. Now let us move to the second kind of equation. So we have a difference equation, like two difference equation, and mostly you will be solving difference equation like this, maybe some nonlinear terms, but the process remains the same. This is xn plus 1 equal to 1.3 xn plus 0.4 yn, and yn plus 1 is minus 0.6 xn plus 1.05 yn. So if I just want to calculate, so I put this value is 0 and the next value is 0 plus 1, and let me drag them to 10 values. Let me change the font to 20, make them bold and center. Now, the initial value I have chosen this to be 100 and this to be 8000. Give a little gap. Now, I calculate x n plus 1 equal to. So, if I put n equal to 0 here, this is 1.3 x0 plus 0.4 y0. So, I will type here 1.3 times x0, which is this value, plus 0.4 times y0, which is this value, and enter. Similarly, this is equal to minus 0.6 times x0, which is 100, plus 1.05 times yn. So, I highlight these two values, go here and calculate up to 10 values. Okay. Now, if I want to plot them, I highlight these values, go insert and plot this. If I want to change this title, I just type this is dynamics of something. So, you replace something by whatever problem you are dealing with, and if you want to change the series, it remains the same. You go to this chart design, select this data, select series 1, edit, and I name it, it's a data 1, and series 2, go to edit and data 2. And you get this kind of dynamics. So, that is how you solve a difference equation consists of two variables. It could have happened that this is yn square. In that particular case, you just multiplied yn into yn. So, that is the only difference when you get the nonlinear terms of, suppose this is xn into yn. So, instead of only multiplying this yn, you have to multiply the component xn also. There is one small difference which you have noticed, that this 1.3. So, instead of taking some a equal to 1.3 and multiplying by this value and then putting a dollar sign, you could have directly multiplied by the constant, which is 1.3 and 0.4. So, So, that also gives you the same result. But sometimes in a long calculation where these constants also need to be specified, there we choose a cell and then you multiply it by that particular value with a dollar sign. Like in this particular example, I have kept changing the value of this k. So, if I put 1.5 here in the equation, then I have to change that equation again and again. So, instead I put this and I put a dollar sign. So, both are correct and you can use both in getting the solutions. We now solve a nonlinear difference equation with the help of Microsoft Excel. So, as you can see, the equation is xn plus 1 equal to xn plus 2.5 yn minus 0.1 xn square minus 1 and yn plus 1 equal to yn plus 5 by xn minus 1. Initially, we have taken that at n equal to 0, the value of x0 is 3 and the value of y0 is 1. So, we first write this with an increment of 1 and let me drag this 68, maybe a little more, okay, up to this much. Then this. So, this is equal to xn, which is this, plus 2.5 multiplied by yn minus 0.1 times xn square minus 1. So, I get this value. Let me drag this one. This is equal to yn plus 5 divided by xn minus 1. So, let us take up to 20 values. So, now we plot, we select these numbers, you go to insert, go to charts and select this. So, if you want to write this, you write nonlinear difference equations for this series. You go to chart design, you select data, you edit and you write this as xn. Similarly, series 2, go to edit and write this as y. And so, you just solved a nonlinear difference equation and get these two curves. Later on, you will be solving the model which will represent this nonlinear difference equation, and from there you will get this curve from which you have to interpret. So, with this we come to the end of this particular lecture, where you have learned that how you can solve a difference equation with the help of Microsoft Excel. So, as you go along, you will come across the models which will be represented by the difference equation, and you will be using this Microsoft Excel to get the solution and its corresponding visualization. In my next lecture, we will be talking about the stability analysis and the equilibrium points of the difference equation. Till then, bye bye.